Okay, so the second video here is going to talk about something called the discriminant. Okay? And the discriminant is a tool that allows us to determine how many roots do we have. And not only just how many roots, it's really hard to write on this, how many roots or how many solutions, how many x-intercepts, okay? And also, what kind? Are they real? Are they real solutions? Are they imaginary solutions? Okay? So here's how we determine, well, let's first of all talk about what the discriminant is. The discriminant is part of the quadratic formula. The discriminant is the part underneath the radical. It's just the b squared minus 4ac. That's the discriminant. Okay, so it's just the part underneath the radical. And so if you look on your paper, okay, you've got 3 bullets, right? And we're actually on the third, well, I guess it's the second page. It's the front of the second page of your stapled notes, okay? But you've got 3 bullets. So if the discriminant is positive, if there's a positive number underneath the radical, then what's happening is you're getting 2 real solutions. They're real numbers, and that means that the parabola, whether it opens up or whether it opens down, it doesn't really matter. But the point is the parabola is crossing the axis 2 times. Okay? It's crossing the axis in 2 different places. Whether it opens up or down, it doesn't matter. It means you're crossing the axis at 2 places. Okay? And that's, again, if the discriminant is positive, if you got a positive value. If the discriminant is equal to 0, and if you want to refer back to the second example we did, if the discriminant is equal to 0, then what that means is you have 1 real solution, or 1 real x-intercept, 1 real 0, 1 real root. Okay? So 1 real solution. It's a real number. And this is that situation where the parabola, again, the parabola can open up or down, it doesn't matter. But the parabola just sort of sits right on top of the x-axis. That's if it opens up. If the parabola opens down, then, like I said, the vertex is the only point that sits on the axis. Okay? It could also, the parabola could also be, the parabola also could be like right at 0, 0. It doesn't have to move side to side. It could just be like right there, like that. Okay, so that's what happens if you have 1 real solution. And again, that takes place if the discriminant is equal to 0. So the third scenario is if the discriminant is negative. So b squared minus 4ac is negative. You have 2 complex or imaginary solutions. Okay? 2 complex solutions. And again, I'm going to use these words, the roots, the x-intercepts, the zeros. These are all the same things. Okay? By the way, complex solutions always come in pairs. They always come in 2s. You can never just have 1 complex solution. You'll always have 2. Think about why you'll always have 2. Because in the quadratic formula, you're always going to have that plus or minus. So it's always going to give you, let's say, 1 plus I, 1 minus I. Or 2 plus 3i, 2 minus 3i. The plus or minus is always going to give you a pair of complex solutions. So what does that look like on the parabola? Again, if it opens up or down, it doesn't matter. If the parabola opens up, that means it floats somewhere above the x-axis. And it never ever crosses the x-axis. If the parabola opens down, it floats somewhere below the x-axis again, never ever crossing. Never ever crossing. Okay? So, if you sort of look down towards the end of your paper, basically what the rest of your notes ask you to do is to calculate just the discriminant. So you don't have to do the whole quadratic formula, just the discriminant. So I'm going to do one of these with you, and then I'm going to leave you to try the rest on your own. So if you look at example 4, part A, you've got x squared plus 6x plus 10. And the directions ask you to calculate the discriminant and give the number and the type of solutions. Okay, so it's not asking you to actually figure out what the solutions are, just the number and the type. So the way that we can do that very quickly is we can label A, B, and C. A is going to be 1. B is going to be, I'm sorry, I made a mistake here. I made a mistake. This should be a minus 6x. I'm sorry. So this should be a minus 6, and then C should be a 10. Okay? All right. So the discriminant is just going to be B negative 6 squared minus 4 times A times C. So negative 6 squared is 36, and then negative 4 times 1 times 10 is going to be minus 40, and so this is going to be negative 4. So on this page, look at your 3 bullet points. Look at your 3 bullet points, and you'll see that on the third bullet, our discriminant is less than 0. Our discriminant is negative. Okay? It's negative 4. So because the discriminant is negative 4, what that means is, for example 4, part A, we have 2 complex or imaginary solutions. If you answer that you have imaginary solutions, complex solutions, the same thing. Imaginary, I'll write that too. If you're going to say we have imaginary solutions, they always have to come in pairs. So we have 2 complex solutions, okay? And that's basically all you have to do for part A, okay? And you can see underneath, you can see sort of the answers there, all right? So I've given you 2 more, B and C, so calculate those, compare your answers, and then down at the bottom of your notes, the last couple of problems, there's a number 4, number 5, okay? It says calculate the discriminant, and then tell the number and the type of the solutions there will be. Okay, so try to work these problems out. You've got some other practice problems in your packet. Okay, so try to work out the other problems that I've given you for the quadratic formula and the discriminant, and then tomorrow I'll have an extra handout to work on. And then hopefully when I come back on Monday, you guys can ask questions and have a pretty good idea about what it is you're supposed to do. Okay? I miss you guys so much. I can't wait to see you. Bye!